right, last example in this section. Probably will end up doing 2 videos for this example. We'll see. This is the same kind of problems that we've been doing, but it's going to take a little bit more work to work this one out. And the reason is that the problem is a little bit more realistic. So this time we're only told the amount of bacteria present after 2 hours and then after 6 hours. So it's almost like we're given 2 data points on the curve. In fact, that's exactly what it is. We're given 2 data points on the curve, and we're supposed to figure out the rest of the curve from that information. And so the first sentence is just telling us that we're assuming a constant relative growth rate, which is the same thing as assuming that the rate of change or the growth rate of our bacteria is proportional to the amount of bacteria present. So that's the same assumption we've been making in all of these problems. And so we're given these 2 data points, and we need to figure out both P naught and K. And so that's what A and B are asking. A is saying relative growth rate, that's our K. B is saying find P naught. Once we've got A and B, C is easy. Once we've got C, D is easy, and then we'll have to figure out E and F from the rest of those. So let's go ahead and dive in. So for us, T is going to be time in hours, and we're going to let P of T equal the amount of bacteria, I will say, at time T. And so we know that P of T, of course, is by our assumption, is going to look like P naught e to the KT, and our job is to find P naught and K. And so part A says find K. So I want to translate this information, this and this, in terms of our function P. I'll use a different color for them so we can keep track of them. So for example, we're told P of 2 is 400, and we're told P of 6 is 25,600. All right? And now what I want us to do is I want us to think about what we're told and rephrase it. P of 2 equals 400. I can rephrase that as P naught e to the 2k equals 400. And I can rephrase the second information, the second point, as P naught e to the 6k equals 25,600. And so I'm just sort of translating both of those things, and I get to there. And so now what I'm going to do is I'm going to take both of those equations, and I'm going to solve for k in terms of P naught. And I'm going to get k equals blah and k equals blah, and the blah is going to be different in each one. And if I set those equal to each other, I can solve and figure this thing out. So that's the plan. So even though A asked for k first, we might end up finding P naught first and then using it to solve. Okay, it doesn't really matter. Here we go. So from the first one, let's just put some dots here. And so from this first equation, I can go ahead and say, all right, well, that means that e to the 2k is 400 divided by P naught. You should be comfortable with that. And then I can say that 2k is the natural log of 400 divided by P naught. And so finally I can say, well, k is 1/2. Actually, you know what? Let's pull that inside. And k is natural log, yeah, hold on. I should write it out so you can see it. So k is 1/2 natural log of 400 over P naught, which is the same thing as the natural log of the square root of 400 over P naught. You can pull that power in as an exponent there and solve. And so there's k from the first equation. Now let's just put a little dotted line here. And now we're going to solve for k from the second data point. And I'm going to get something different, but I know they have to be the same. So from the second data point, I can say, well, e to the 6k is 25,600 divided by P naught. And so then I get what? 6k is the natural log of 25,600 over P naught. And so I get K is 1 over 6 natural log 25,600 over P naught. Okay, I've got two different expressions for K. I might end up not using the square root because I have a 6 here. I don't want to bring that in as a 6th root. That gets messy. But the point is, here's a K and here's K, and those two things have to be equal to each other. They absolutely have to be equal to each other. And so that leads us to the following equation. I'm going to switch colors here just to try to help you keep track of it. So I now know that 1/2 the natural log of 400 over P naught has to equal 1/6 the natural log over 25,600 over P naught. Okay? And so now at this point, there's lots of ways you can proceed. I'm going to go ahead and clear this fraction right here, these fractions. I'm going to multiply the equation by 6. And so I get 3 natural log of 400 over P naught is just the natural log of 25,600 over P naught. And now at this point, if you have just a natural log of something equals natural log of something, you can drop the logs. This 3 is killing me. So what I'm going to do is bring it in, and I'm going to write this as the natural log of 400 cubed over P naught cubed equals, equals natural log of 25,600 over P naught. And now I can actually drop the logs. And so I know that 400 cubed, whatever that is, divided by P naught cubed is 25,600 over P naught. Okay, so cross multiply. Yeah, if you want to expand 400 cubed, you can. I don't particularly feel like doing that yet. It's easier for me to write it as something cubed. And so the point is, I get what? P naught times 400 cubed, maybe a parenthesis will help you keep careful track of it, equals 25,600 times P naught cubed. When you cancel a variable, you should be really hesitant to do that because you're losing the possibility that P naught is 0. But P naught is an initial population, and if we start with 0 bacteria, we're not going to have any growth. So we know P naught isn't 0, and so I can safely cancel a P naught. And so I end up with 400 cubed is 25,600 times P naught squared. And so I'm going to solve, and I get 400 cubed over 25,600 equals P naught squared. And so when I solve for P naught, I get the square root of 400 cubed over 25,600. I'm going to erase this just a little bit. Yeah, wow, that looks awful. But pull out your calculators and simplify, and you actually just get 50. So look at that. We figured out what P naught was. Now we have to figure out what K is. So I'm going to go back, either formula. I'm going to go right here. I'm actually going to copy this guy. I'm going to copy this, and I'm going to plop it in right here. And so now that's a kind of hard to read, but that's a P naught right there. And so the point is, let's switch colors to something that we can see over here. And so the point is, when you plug this in, K is 1/2 natural log of 400 over 50, which is just 8. So K is 1/2 natural log of 8. And so we did it. We've got P naught, we've got K, and so we can actually put this all together. Part A said find K. So K is 1/2 ln of 8. Part B said find P naught. P naught is 50. And then part C was put it all together for a formula for the amount of bacteria present. And so that's going to be 50 e to the K 1/2 ln of 8 times T. So I'll end this video here, and in the next video we'll figure out the other parts.